Assalamu alaikum. This is Kamrul Hassan, lecturer, Department of Mathematics, Milestone College. My dear students, I hope you are doing well. Today, I want to discuss about some mathematical problem from exercise 9b. First of all, I want to discuss about some important formulas which is very helpful for your mathematical problem. Look at this here. Formula number 1. ddx of x to the power n, it will be n into x to the power n minus 1. And formula number 2, ddx of x, it will be 1. Look at this here. Suppose ddx of x here, exponent of x, it will be 1. So that means we can write here 1 into x to the power 1 minus 1, so it will be x to the power 0. X to the power 0 means 1. That's why ddx of x equals to 1. Now ddx of root over x, it will be 1 by 2 root over x. And formula number 4, ddx of sine x equals to cos x. And here ddx of cos x, it will be minus sine x. Here formula number 6, ddx of tan x, it will be sec square x. Here formula number 7, ddx of cot x, it will be minus cosec x square, cosec square x. Formula number 8, ddx of sec x, it will be sec x into tan x. Okay. Now formula number ddx of cosec x. So we can write here minus cosec x into cot x. And formula number 10, ddx of e to the power x, it will be e to the power x. Formula number 11, ddx of a to the power x, we can write here a to the power x into ln a. And formula number 12, ddx of ln x, so we can write here 1 by x. Here formula number 13, ddx of log a to the power x, so we can write here 1 by x into log a to the power e. And last one is ddx of c. C means constant, so we can write here 0 because here there is no x variable, so c is a constant, and here we can write ddx of c equals to 0. Now mathematical problem. Look at this. Determine the derivatives of the function below. Let x is a variable. Our first mathematical problem is 27, question number 27. Here 2x to the power 3 minus 4x to the power 5 by 2 plus 7 by 2 into x to the power minus 2 by 3 plus 7, which is a one kind of algebraic expression. Now let y equals to 2x to the power 3 minus 4x to the power 5 by 2 plus 7 by 2 into x to the power minus 2 by 3 plus 7, and which is the one kind of function. Now we can write differentiation with respect to x. Differentiation with respect to x. We get, look at this here, we get ddx of y equals to ddx of 2x to the power 3 minus 4x to the power 5 by 2 plus 7 by 2 into x to the power minus 2 by 3 plus 7. here 2 is a coefficient of x to the power 3, 4 is a coefficient of x to the power 5 by 2, and 7 by 2 is a coefficient of x to the power minus 3 by 2, and 7 is a constant. So we can write here, look at this, 2 into ddx of x to the power 3 here minus 4 into ddx of x to the power 5 by 2, and for this term we can write plus 7 by 2 into ddx of x to the power minus 2 by 3, and for this part we can write plus ddx of 7. Now for this term, look, all we know that the formula of ddx of x to the power n, ddx of x to the power n equals to n into x to the power n minus 1. And now applying this formula on this term, we can write here, look at this, 2 into, suppose 3 is n and x variable is this x variable, so we can write 3 into x to the power 3 minus 1, and for same procedure for this term, minus 4 into, here look at this, 5 by 2 into x to the power 5 by 2 minus 1, and for this term we can write 7 by 2 into, look at this, minus 2 by 3 into x to the power minus 2 by 3 minus 1, and last one is ddx of 7. Here 7 is a one kind of constant, so all we know that the formula of ddx of c equals to 0. Here c means constant, so ddx of c equals to 0. Here 7 is one kind of constant, so we can write here ddx of 7 equals to 0. Now after this line we can write, look at this, 2 into 3, it will be 6, and x to the power 3 minus 1, it will be 2, minus here 4 into 5 by 2, 4 into 5, it will be 20 by 2, so we can write 10. Here look at this, x to the power 5 by 2 minus 1, so after calculation it will be 5 minus 2, so we can write 3 by 2. Here x to the power 3 by 2, and now for this part, here 2 and 2 will be cancelled. After cancellation we can write here plus and minus, it will be minus, so we can write 7 by 3, and here x to the power minus 2 by 3, look at this, here minus 2 by 3 minus 1, so we can write 3, apply LCM method, we can write here minus 2 minus 3, so it will be minus 5 by 3. Okay, here minus 7 by 3 into minus 5 by 3. My dear student, look at this. Here, this is the required answer of question number 27. Now, question number 34. Here, after this line, we can write here, let, look at this, let y equals to x minus 3 log a to the power x plus 5 cos x. Now differentiation with respect to x, with respect to x, and here, and we get we get. So we can write here ddx of y equals to here ddx of x minus 3 log a to the power x plus 5 cos x. Now after this line equals to here ddx of x, and 3 is the coefficient of log a to the power x, so it will be minus 3 into ddx of log a to the power x plus 5 ddx of cos x. Here look at this. Now for this term we can apply the formula of ddx of x to the power n. Look at this. Here ddx of x to the power n, it will be n x to the power n minus 1. That here only x. Suppose ddx of x to the power, look at this, here x to the power 1, so here x, so it will be x to the power 1. So after this line it will be 1 into x to the power 1 minus 1. That means here look at this, x to the power 0. X to the power 0 means 1, so ddx of x, it will be 1. Now we can write here ddx of x, it will be 1, and here minus 3 into, look at this, ddx of log a to the power x, and here we can apply the formula of ddx of log a to the power x. It will be the differentiation of log a to the power x will be here 1 by x into log a to the power e, and this is the formula of log a to the power x. So now applying this formula on this term, so here it will be 3 into, for this part it will be 1 by x into log a to the power e, log a to the power e, and here look at this, 5 into ddx of cos x, and all we know that the differentiation of cos x, that means ddx of cos x, it will be minus sin x. So here we can write plus 5 into, for this part it will be minus sin x, and now after this line we can write here, after this line we can write here, it will be equals to here 1 minus 3 into 1 by x, it will be 3 by x at log a to the power e. So we can write here log a to the power e, and for this part here look at this, 5 into minus sin x. So after this, after calculation it will be minus into plus, it will be minus, so we can write here minus 5 sin x, okay, and this is the required answer of question number 34. Now question number 41, here look at this, cos x minus cos 2x by 1 minus cos x. So we can write here, let y equals to cos x minus cos twice x, and here 1 minus cos x, and after this line here look at this, all we know that the formula of cos 2x, it will be cos square x minus sin square x. So it will be cos x minus, look at this here, cos 2x. The formula of cos 2x, cos square x minus sin square x. This is the formula of cos 2x. So now applying this formula on this term, so it will be cos square x minus sin square x, and now here 1 minus cos x. 1 minus cos x will remain unchanged. So here now look at this, cos x, here minus cos square x, it will be minus cos square x, and here minus and minus it will be plus, so we can write here plus sin square x, and now here 1 minus cos x. And now after this line we can write here y equals to, look at this, cos square x and cos x. Here from these two parts we can take a common part, it will be cos x. So we can write here cos x into 1 minus cos x, 1 minus cos x, and now for this part sin square x, and all we know that the formula of sin square theta plus cos square theta equals to 1. So that's why we can write here sin square x equals to 1 minus cos square x, and here 1 minus cos x, and look at this, after this line here y equals to, and here we can apply the formula of a square minus b square. So it will be cos x 1 minus cos x plus here 1 minus cos square x. So we can write here 1 plus cos x into 1 minus cos x. Okay, 1 minus cos x. So look at this, from these two part we can take the common factor of 1 minus x from these two parts. So it will be y equals to, here common factor is 1 minus cos x, so it will be 1 minus cos x, and here remaining part it will be cos x plus 1 plus cos x, and here 1 minus cos x. Now for this part, here look at this, 1 minus cos x and 1 minus cos x will be cancelled. So after calculation it will be y equals to cos x plus cos x, it will be 2 cos x, and here 1. So we can write here 1 plus 2 cos x. Okay, now we can now differentiation with respect to x for this part. So we can write here this, here differentiation with respect to x, and we get here, look at this, y equals to 1 plus 2 cos x. So it will be ddx of y equals to ddx of 1 plus 2 cos x, and here equals to, we can write here ddx of 1, and plus here 2 is a coefficient of cos x, so it will be 2 into ddx of cos x, and here now applying the formula of, here look at this, ddx of 1, here 1 is a constant term, so all we know that the formula of ddx of c equals to 0. That means here there is no x variable, so ddx of c it will be 0. And for this reason, here ddx of 1 it will be 0 plus here 2 into, all we know that the formula of ddx of cos x it will be minus sin x. ddx of cos x it will be minus sin x. That's why here we can write ddx of cos x it will be minus sin x. And here, so after this line we can write here minus 2 sin x, minus 2 sin x, and this is the required answer of question number 41. My dear student, no more today. See you again in the next class.